If it is not satisfying this optimality condition, we can go further for next iteration. If you get negative or infinite value, you need to select only the least positive value. Old value is 0, corresponding key column is 2 and corresponding key row is 1. So 0 minus 2 into 1 by 2. Hello my dear students, welcome back to my new session. I am Shweta, Computer Science faculty, Vidhyaashram First Grade College, MYSURU. In my last session, I have discussed about simplex method. If we have more than two variables, we can go for simplex method. Simplex method is a standard technique for finding the optimization problem. So let's get started now. So today I will discuss simplex method problems. So first problem. In last session, I have discussed about the standard format, right? So first you have to check whether it is maximization or minimization problem. So if it is minimization, you just convert this into maximization by multiplying minus 1. So first observe this maximization or minimization. Then you just see the constraints now. Here we have two constraints. So less than or equal to, less than or equal to. So in simplex method, you have to find the solution by maximization type only. And you just see the RHS value, all the RHS value should be positive. Then if it is negative means you just convert it into positive by multiplying minus 1. Now all the RHS value is positive only. Next I will convert this into standard form. I'll write the maximization first. Max z is equal to x plus 1.5 y. And the first constraint is subject to constraint x plus 2y. I am converting this into inequality format into equality by adding the slack variable is equal to 160. Those who have not seen my last session, please watch the first session of simplex method. Easily you can understand each and every concept. So here I have converted this into standard form. This is equation number 1. And the second constraint is 3x plus 2y plus s2. I am adding the slack variable for converting the inequality into equality 240. So here I have two slack variables s1 and s2. I will write this slack variable with 0 coefficient in objective function. Now this is in a standard form. So first write the objective function and convert this constraint into standard form, converting inequality into equality by adding the slack variables. So this is in a standard form. Then after that we have to find the initial simplex table. Initial simplex table. So in initial simplex table, just write this table first and common thing is Cj, that means coefficient of objective function. So what are the coefficient of this objective function? 1, coefficient of x is 1 and y is 1.5 and s1 is 0, s2 is 0. Coefficient of objective function. And what are the decisions variable we have taken? That is x, y, s1 and s2, basic variables. And again here I have two slack variables. I will write here two slack variables s1 and s2. And what is the coefficient of slack variable? It is 0 and 0. So this is the first thing you have to write in table. After that, so first thing is you just see the coefficient of x, y, s1 in equation number 1. Coefficient of x is 1. Coefficient of y is 2. Coefficient of s1 is 1. Coefficient of s2 is not there, so it is 0. And the solution is 160. So this is the coefficient of equation number 1. And just see the equation number 2 and write the coefficients here. So x coefficient is 3, y coefficient is 2, s1 is not there, s2 is there, it is 1 and the solution value is 240. So this is your given value. First write this table and now find Zj and Cj minus Zj. So what is Zj? 0 into 1 plus 0 into 3. It is 0 only. and 0 into 2 plus 0 into 2, it is 0. 0 into 1 plus 0 into 0, 0. 0 into 0, 0 into 1 is 0. So, in initial simplex table, we will get all the Zj values is 0. So, here after finding the Zj value, you just subtract this Cj minus Zj, 1 minus 0, 1. 1.5 minus 0, 1.5. 0 minus 0, 0. 0 minus 0, 0. So, this is your Cj minus Zj value. So, first find out this in initial simplex table. After that, you just see the value of Cj minus Zj, 1, 1.5, 0 and 0. Here, we have plus 1 plus 1.5. In my last session, I have told you about the maximization and minimization value for optimality condition. For maximization, all Cj minus Zj should be less than or equal to 0. All Cj minus Zj value should be less than or equal to 0. That means it should be negative or it should be 0. So, here we have two possible values and two zeros. Here we have two positive values means this value is not satisfied optimality condition. Is not satisfied optimality condition. If it is not satisfying this optimality condition, we can go further for next iteration. So, before that you have to find the key column and key row, and also you have to find key element. That is the main thing you have to find in initial simplex table. So, how to find the key column here? You just see the Cj minus Zj value and mark the maximum positive value. So, here 1 is there and 1.5 is there. The maximum value is 1.5. This is maximum value in Cj minus Zj. So, this maximum value comes under the column called Y. This column is called as key column. So, this maximum value, it comes under the column called Y column. This column is called as key column. Except this Zj, you can mark this is your key column. So, Y is key column. If it is key column means it is called as entering variable. So, Y is entering variable. Entering variable. And after finding this key column, you can find the key row also by using this ratio. So, find the ratio value. How to find the ratio value? So, solution divided by key column. Solution divided by key column. So, what is the solution values? 160 divided by 2. So, 160 by 2 it is 80. So, ratio value for first key column is 80 and solution by key column is 240 divided by 2. It is 120. So, here we got ratio values 80 and 120. For finding the key column, we have to find the maximum value in Cj minus Zj. For finding the key row, we have to select the minimum value in ratio. So, the minimum value is 80. So, this is my key row. This is my key row. This 80 comes under S1 variable. So, this is my key row. So, here the key column is Y, key row is S1. S1 means it is a living variable. Living variable is S1. Living variable is also called as outgoing variable and entering variable is also called as incoming variable. So, now living variable is S1. I will replace this S1 by Y because Y is my entering variable. So, in next iteration, I will replace this S1 by Y because Y is my entering variable. I will delete this S1 and in place of S1, I will write Y because Y is my entering variable. So, now we got to know about the key column and also key row. And now we have to find the key element. So how to find the key element? The common element for both key column and key row. I'll repeat, the common element for both key column and key row is 2. Common element for both key column and key row is 2. So key element or pivot element is equal to 2. 2 is my key element because it is common for both the column and key row. So key element is equal to 2. So now we can proceed for the next iteration called iteration 1 because here we got only positive value and 0. For all maximization problem, Cj minus Zj should be negative. So till that we have to find the iterations. So this is your initial simplex table. If it is not satisfy the optimality condition, we have to find the key column, key row and key element. Then replace this entering variable by leaving variable. The next table is iteration 1. In first iteration table, again write the value of Cj, basic variable and coefficient. So what is Cj? Coefficient of objective function, that is 1, 1.5 and S1 is 0, S2 is 0 and basic variables x, y, S1 and S2 and solution and ratio. After that, here you have to write the basic variable. So this is leaving variable. In place of S1, I will write y because it is entering variable. So y and S2. Now, what is the coefficient of this y? Coefficient of y is 1.5. I will write here 1.5 and coefficient of S2 is, it is 0 only. So next step is, here in previous table, we have key row and non-key row values. So in iteration 1, you have to find the new values. So using this old values, key row and old values, you have to find the new values. So first step, I will find the key row values. Here I have old key row values. I will find the new values in iteration 1. So first list all the key row values 1, 2, 1, 0, 160. 1, 2, 1, 0, 160. 1, 2, 1, 0, 160. Have listed the key row values. So how to find the key row? Key row is equal to old value by key element. So what is the key element? Key element is equal to 2. So key element is 2. In iteration 1, you have to find the new values. So key element is equal to 2. Old value is equal to 1. 1 by key element is 2. It is 1 by 2. I will write here 1 by 2 and old value is 2. 2 by 2 is equal to 1. And old value is 1. Key element is 2. So it is 1 by 2. Old value is 0. Key element is 2. It is 0. Old value is 160. 160 by 2 is, it is 80. And now we have to find the non-key row values. So non-key row values are 3, 2, 0, 1, 240. 3, 2, 0, 1, 240. 3, 2, 0, 1, 2, 40. So what is the formula for finding the non-key row? Old value minus corresponding key column into corresponding key row divided by key element. So this is the formula for finding the non-key row values. So old value is 3 minus corresponding key column into corresponding key row. So old value is 3 and the corresponding key column is 2. This is row, this is key row and this is key column, right? So old value is 3, corresponding key column is 2 and the corresponding key row is 1. Old value is 3, corresponding key column is 2, key row is 1. And again to this number, old value is 2, corresponding key column also 2 and the key row is 2. So key column is same for all the numbers. Old value is 3, corresponding key column is 2 and corresponding key row is 1. So 3 minus 2 into 1 by 2. 3 minus 2, key row is 1 divided by key element. So 2 get cancelled, 3 minus 1 is equal to 2. I will write here. And old value is 2, corresponding key column also 2 and key row is 2 divided by 2. 2 minus 2 into 2 divided by 2. 2 minus 2 into 2 by 2. So 1, 2 get cancelled. 2 minus 2 is equal to 0. And old value is 0. Corresponding key column is 2 and corresponding key row is 1. So 0 minus 2 into 1 by 2. 0 minus 2 into 1 by 2. 2 get cancelled. It is minus 1. And old value is 1. Corresponding key column is 1. Key row is 0. So 1 minus 2 into 0 by 2. 1 minus 2 into 0 by 2. It is 1. And old value is 240. Corresponding key column is 2. Key row is 160. So 240 minus 2 into 160 by 2. 240 minus 2 into 160 by 2. 2 get cancelled. 240 minus 160 is equal to 80. So it is 80. So now we can find Zj. 1.5 into 1 by 2. It is 1.5 by 2 plus 0 into 2 is 0. And 1.5 into 1 plus 0 into 0. So it is 1.5. And 1.5 into 1 by 2, it is 1.5 by 2 plus 0. And 1.5 into 0 is, it is 0. 1.5 into 8 is 120. You can find Cj minus Zj. 1 minus 1.5 divided by 2. 1 minus 1.5 by 2. Take LCM. 2 minus 1.5 by 2. It is 0.5 by 2. So write this 0.5 by 2 here. And 1.5 minus 1.5, it is 0. And 0 minus 1.5 by 2, it is minus 1.5 by 2. And 0 minus 0 is 0. So here all the three values are satisfying, but this first value is positive 0.5 by 2. It is not satisfied optimality condition again. So it is not satisfying. Not satisfied optimality condition. We can proceed. Not satisfying optimality, then we can proceed for the second iteration. Before that, we have to find the key column, key row and key element also. So here the maximum positive value. For finding the key column, we have to check the maximum positive value in Cj minus Zj. The maximum positive value is 0.5 by 2. It comes under the column called X. This is my key column. And after finding the key column, we can find the ratio, that is 80 divided by solution by key column. 80 by 1 by 2. 80 divided by 1 by 2 means it is 160. So 1 by 2 will shift it to the numerator. 80 into 2 is 160 and 80 by 2. 80 by 2 is 40. So here now we have to find the key row. For finding the key row, we have to select the least positive value in ratio. Listen carefully. If you get any negative values, if you get all the values are negative, so it is called as unbounded solution. If you get negative or infinite value, you need to select only the least positive value. So here the least positive value is 40. It comes under the row called S2. So this is my key row. So key row is S2. S2 is living variable, and X is entering variable. X is entering variable. Here X is entering variable and S2 is living variable. So in place of S2, I can write this X. So definitely in next iteration you will get the answer. Entering variable is X, living variable is S2. So now we have to find the key element. So which is a key element here? Common element for both key row and key column is 2. So key element is equal to 2. Key element is equal to 2. It is called as pivot element. So next we will find the last iteration, iteration 2. So first write the coefficient of objective function 1, 1.5, 0 and 0. Basic variables x, y, s1, s2, solution and ratio. So here entering variable is x, living variable is s2. So entering variable is x and living variable is s2. So coefficient of x is 1 and the coefficient of y is 1.5. If you get both the variables in this step, definitely you will get the final answer in iteration 2. So entering variable is x and the living variable have discarded s2. So now here you have to find the new values using key row and non-key row. So first list all the key rows 2, 0, minus 1, 1 and 80. Key row 2, 0, minus 1, 1 and 80. So key element is 2. So how to find the key row? Old value divided by key element. Old value is 2, key element is 2, it is 1. Old value is 0, key element is 2, it is 0. And old value is minus 1 divided by key element means it is minus 1 by 2. Old value is 1, key element is 2, it is 1 by 2. Old value is 80, key element is 60. It is 60. And so now find the non-key row values. So just list all the non-key row values. 1 by 2, 1, 1 by 2, 0, 80. 1 by 2, 1, 1 by 2, 0, 80. So first is 1 by 2. So old value is 1 by 2, old value is 1, old value is 1 by 2, old value is 0, old value is 80. So now find the corresponding key column and key element. So old value is 1 by 2, corresponding key column is 2 and the corresponding key row is 1 by 2 only. Old value is 1 by 2, corresponding key column is 2 and key row is 1 by 2. 1 by 2 minus 2 into 1 by 2 divided by 2. 1 by 2 minus 2 into 1 by 2 divided by 2. So 2 get cancelled. 1 by 2 minus 1 by 2 it is 0. And old value is 1. Corresponding key column also 1. Key row is 0. So 1 minus 1 by 2 into 0 by 2. 1 minus 1 by 2 into 0 by 2. It is 1. And old value is 1 by 2. Corresponding key column 1 by 2. Key row is minus 1. So 1 by 2 minus 1 by 2 into minus 1 by 2. 1 by 2 minus 1 by 2 into minus 1 by 2. So 1 by 2 minus into minus plus 2 I will shift it to the numerator. So 1 by 4. So 1 by 2 plus 1 by 4 means here 4 is my LCM and 2 plus 1. So it is equal to 3 by 4. And 0. 0 is the old value. Corresponding key column is 1 by 2. key row is 1. So 0 minus 1 by 2 into 1 by 2. 0 minus 1 by 2 into 1 by 2 divided by 2. 1 by 2 into 1 by 2 is 1 by 4. So it is 0 minus 1 by 4. It is minus 1 by 4. Minus 1 by 4. And the last value is, so old value is 80, corresponding key column is 1 by 2 and key row is 80. So 80 minus 1 by 2 into 80 by 2. 80 minus 1 by 2 into 80 by 2. So 2 ones are 2 40s are 2 ones are 2 20s are 80 minus 20 is 60. So here we got 60 and 40. Now find the value of Zj. 1.5 into 0 is 0. So 1 into 1 is 1. And 1.5 into 1 is 1.5 plus 0. So next 1.5 into 3 by 4. Find 1.5 into 3 by 4. Plus into minus minus 1 into 1 by 2, you will get 2.5 by 4. And 1.5 into minus 1 by 4 plus 1 by 2, you will get 0.5 by 4. You just take LCM. 1.5 into minus 1 by 4 plus 1 into 1 by 2, you will get 0.5 by 4. So now you can find the Cj minus Zj. 1 minus 1 is 0. 1.5 minus 1.5, 0. 0 minus 2.5 by 4, it is minus 2.5 by 4. And 0 minus 0.5 by 4, it is minus 0.5 by 4. So now we can cross verify the optimality condition. So this value is satisfied the optimality condition because all the values are 0 or negative. If it is 0 or negative, for maximization, it can satisfy optimality condition. So all the values are satisfying optimality condition. Satisfied optimality. Optimality condition is satisfied. And also you can find the Zj value here. 1.5 into 60 plus 1 into 40. You will get 130. So now Zj value max Z is equal to 130 and X value is 40 and Y value is equal to 60. X value is 40 and Y value is equal to 60. So Zj value is 130. You can cross verify the answer. Max Z is equal to 130 X plus 1.5 Y. So max Z is equal to 130 into X value is 40 plus 1.5 into 60. So we will get 130, 130. So LHS is equal to RHS, hence it is proved. So this is about your simplex method. In my next session, I will discuss the minimization problem. Thank you.